Thanks all for joining. Welcome to Upper Bound here. Nice way to kick off the day. Thank you to the city for hosting us and for the organizers. It's looking really good. I think people are just getting seated, so we'll do a bit of a soft launch here. Today we're going to be talking about sovereignty, sovereign AI, sovereign compute, sovereign energy. Why is it important? What are we getting right? What are some of the things we need to do better? And I hope this is a really meaningful discussion that people can walk away from and consider their supply chain. Is it set up correctly here? In order to have this conversation, I'm going to need some help. So I've brought three colleagues along here. First, we've got Griffin Lacey coming from Nvidia. He's a manager of solution architects in Canada. And then we've got Adi Raj joining us from HPE, solution architect on that side. And then I hope I can say close friend and colleague here, Glen. Probably the only person I know that can really push the legendary patience of AI to the limit. He's joining us from Telus and leads our business development team there. I'm Andrew Shakespeare, and I lead the product organization for our AI factories at Telus. So thank you all for being here.
We'll see what types of questions he asks before we'll say if we're good friends or not.
And please do chime in with what you're interested in, what you're working on as we go through some of these questions. So look, the definition of sovereignty is dynamic. It's evolving even from this time last year. It's changed a lot, and it means different things to different people. So I think in order to have a really meaningful discussion, we should start by framing that out and talking through some of the dimensions of sovereignty. What does it really mean? Why does it matter to people, to organizations and citizens as well? So Glen, let's start with you. You're having this conversation almost every day. What does sovereignty mean these days? How has it maybe shifted from the data residency conversation that we've been having for the last decade?
I mean, it really depends on who you talk to. As you said, Andrew, have a lot of different conversations with a lot of different customers. It fundamentally boils down to control, right? And organizations that are and startups and research centers that are developing their intellectual property, that they're developing critical applications for their industry, need to have control of their data. So if you have a data center in Toronto, but the stack that is running it is governed by other entities outside of Canada, you're at risk of losing your access to that data. A lot of people talk about the ability for foreign entities to get access to your data. A lot of organizations don't mind that so much because they typically encrypt their data. And so they think, I've encrypted my data, I've got data residency, so I'm safe. The actual risk out there is action by that foreign government instructing a foreign organization to remove your access from your data. And so if you're in a critical infrastructure organization, you think about the risks to your business. You think about what happens if you don't control it. What happens if your information is taken from you? And when we talk about sovereignty, Minister Solomon last week actually said it's not solitude, right? Sovereignty isn't solitude. Sovereignty is developing in Canada by Canadians for Canadians, and that it's free from outside influence.
Thank you. Griffin, there's so many aspects to this tech stack. Jensen talks about the 5-layer cake. I think there's other analogies as well. This morning we were talking about maybe some of the icing that goes on top of that cake. Can you help us just walk through the different layers of the stack and maybe which ones are more and less important from a sovereignty perspective?
Yeah, absolutely. Jensen laid out this really nice analogy to simplify how we think about the AI stack. And a lot of people, when they think of Nvidia, they think of chips. And that's certainly true that Nvidia does build the parallel computing devices, the GPUs, but that's not the lowest layer of the stack. So he describes it as this 5-layer cake. And the first layer, if we start at the bottom and work our way up, is energy. And energy is really critical because AI is increasingly very hungry for power. And really the energy, the electricity, the moving electrons, those are the input into those chips that is going to turn it into some sort of meaningful output. So if the first layer is energy, the second layer is chips, as I've described, and the layer on top of that, the third layer, is infrastructure. And this is everything around the chips. So this could mean anything from, not just the GPU chips, but the networking chips, the storage infrastructure, CPU infrastructure, all the way to system, software, and infrastructure. I would also argue that you would want to include the CUDA ecosystem in there as well. So the software ecosystem that enables developers to use those GPUs, that's all a really important part of that infrastructure layer. And then the last two layers on top of that, you have models. I think that's where a lot of us think about what AI is they think about, this model, right? This Claude model, this ChatGPT model. That's how I think about AI, but that model is dependent on every layer of the stack beneath it, right? Dependent on the infrastructure, on the chips, on the energy. And then above that, we have applications, which are attempting to make some meaningful creation from those models in the layers beneath it. So think about autonomous vehicles, think about humanoid robots, right? Those are applications that are using those models to do something meaningful and useful for us every day. And so when we think about sovereignty, we're really talking about the lower layers of the stack. We're talking about the energy, we're talking about the chips, we're talking about the infrastructure. And I would argue that those are the most critical pieces to, as Glenn talked about owning that capacity, that capability, is owning the lower layers of that stack. I think that's really important for us in Canada and as Canadians to think about, not being dependent on, foreign nations for that part of our infrastructure. Because I would argue that AI is becoming critical infrastructure in the same way that electricity or roads are critical infrastructure. And so we really don't want to depend on other nations for that critical infrastructure that can be so important to our economic future.
I'd agree. And when it comes to the criticality of this national resource now, I think immediately we might say, well, I want all of that to be sovereign. I want as much of the stack here as possible. And look, I would love to have sovereign fabs, to de-risk some of the stuff in Taiwan and TSMC. I'd love to have sovereign lithography machines, these giant machines that build the chips, super complex. But that is so far away and maybe something that's hard to realize. So Adi, over to you now. Given the stack and the different components in it and the criticality of each, what is a reasonable, achievable today stack look like for compute and data processing?
Yeah, definitely. So as like the Tyler cake example, moving on to Griffin, it's kind of like that frosting that makes it more sovereign, how we actually deploy that stack. So obviously working with local energy providers to make sure that's happening on the energy layer. But once infrastructure is actually deployed, how do we actually make it, multi-tenant? Meaning, how can we isolate different compute resources per tenant so that no one's actually, meshing together, not using the exact same resources, so everything's separate, right? So that multi-tenancy is a big factor, coming from the infrastructure layer to then the application layer, right? And then when you move up to the application layer, when we talk about sovereign, like the AI factory, we're not talking about just GPU as a service. We're talking about entire platform, entire ecosystem. So you have the infrastructure and the software layer for training, inference, data prep, data modernization too. So all those things have to be encompassing into one platform while also being able to be easily accessible too. And once you have those foundations, that platform established, then you can go in the application layer, right? You're developing applications, you may be deploying like NVIDIA NIMs that are more secure, open source models, right? Containerized. And then on top of that, we really talk about control and security and your keys, right? You have to maintain a proper audit trail of what you're doing in the entire stack so that when you do maybe run to regulatory or compliance, you have that reference to actually provide. So,
thank you. Before I move on to the next section here, we will talk about energy because it keeps coming up. Are there any other critical components or variables or factors that go into the supply chain risk assessment or business case on sovereignty before we go into energy, or are you guys feeling good? Good so far?
I think that when we talk about supply chain, we do talk about the bits and bobs. I like to call them the whiz-bang 5000s, how fast they spin and how bright their lights are. But I think the value chain that we need to build is that ecosystem of development. And so how does, bringing it back to what I said earlier about intellectual property creation here in Canada, how do we create that value chain to find that Canadian small company that are innovating that could become the Canadian Oracle, the Canadian Microsoft?
They could be here right now.
They could be here right now. And I think that it behooves us as infrastructure providers who are kind of building this across the country of how do we enable these small organizations, they could be on university campuses, how do we give them that access to the technology to develop those applications so that the further you go up the stack, the more sovereign we become.
Right, thank you. So you all brought up energy. First, let's just recognize how lucky we are to live in a world where we take chips and energy and somehow intelligence comes out the other side. It's brilliant and I'm blown away by it every day. Energy supply. It's a big topic right now, probably with job replacement. It's energy, water, and noise from these factories. I want to dive into that a little bit with you. Fortunately, we're here in Alberta, a land of abundant energy, both above and below ground. So there must be an advantage that can be born here. So as we look at the cake and the layers within and the full tech stack, some layers are more critical than others. We actually don't have to use our imagination very much to see why certain aspects of that should be as sovereign as possible. The energy crisis that's unfolding globally right now is a good reminder of this. Anybody who is reliant on those sources of energy is now feeling it, and we can make the same analogy to the compute stack as well. So if there's agreement here that compute, chips, energy are the critical inputs, how do we feed this hunger that AI and ML has for energy without compromising the grid, without impacting the citizens that need that electricity as well and are sharing with these large AI factories? And of course, if possible, tie in the Albertan advantage here and what's the power that we can bring from this province and from Canada. Griffin, I'm going to start with you on this one. Talk us through the power requirements and how we address some of these concerns.
Absolutely. I'll share from an Nvidia perspective that, of course, these models are very hungry for energy, for power. And I would say there's a lot that we can do to help improve the efficiency of the models and of the architecture. I am giving a talk with a bit of a deeper dive on this in a few hours on the same stage, where we talk about the sort of extreme levels of hardware, software co-design that we go through at Nvidia to drive this efficiency forward. Of course, when we release a new microarchitecture, we get power efficiency improvements, right? New process technology, smaller transistors, there's wins from a power efficiency perspective there. But it's not just that. We look at it from an entire platform perspective. So I'll give a deeper dive on some of these areas, but things like low precision math, right? Supporting doing these math operations with fewer bits is incredibly important for power efficiency. Or if you think about on a large scale, things like disaggregated serving. So, in these large modern inference workloads, pushing the right parts of the workload to the right parts of the hardware that will optimize them, whether they're memory bound, whether they're compute bound. And so when you look at all of this together, like we're working really hard, right? Like Nvidia has more software engineers than hardware engineers because we're working very hard to drive efficiencies at every part of the software stack. And I would also make the argument that there's another really important role that is played fundamentally at the research level at institutions like AMI for driving optimizations at the model layer. And so I come from a background where I was studying computer vision kind of through grad school, kind of in the early days after the AlexNet model. And the models that were published that were advancing state of the art on benchmarks looked a bit different from the models that we saw in production years later, because the research community had been able to figure out how to achieve similar accuracy results with fewer parameters. So they were able to drive more parameter efficient model architecture design, which was critically important. I think we're going through a similar behavior now with large language models, where we see at the forefront these foundation models that are pushing state-of-the-art forward, but sometimes, depending on the application, you might be able to get away with a much smaller, more memory-efficient model, more parameter-efficient model. And as Adi suggested, I think there's also an element to be played on the infrastructure utilization piece as well. You talked about multi-tenancy. There's a critical piece here which is driving the right workloads to the right idle parts of the infrastructure to drive utilization higher across the entire design, so that we can make sure that each watt is being used as effectively as possible for producing tokens. So that's kind of the high level view from my perspective at least.
Brilliant, and a few takeaways there, folks. The first is this intelligence per watt or milliliter of water is the worst it's ever going to be right now. That's only going to improve. New model architectures, new chip designs are coming out. Selecting the right model for your use case, critically important. If you want to know what dinner to make with the groceries in the fridge, don't throw Opus at it necessarily every single time, unless you're trying to, prove it to your wife's Italian grandmother that you know what you're doing. And from here, folks, what else is going on in the energy space around data centers where we can try and relieve some of these concerns? And folks, just before this, I was consulting a variety of AI. I played Gemini against Claude, against OpenAI and X, and I was like, look, what is the actual impact that we're having here? There's so much media coverage about the environmental concerns here, and roughly it came back and said, for a relatively high user of AI, which I defined as about 50 queries per day, some may say that's not a lot, some may say that's a humongous amount, it was roughly a 5 to 10% increase in our electricity and water consumption as an individual. Now that is substantial in the sense that it came so quickly and it's expected to grow, but it's also not so dramatic, I think, that the headlines make it out to be here. So then I also asked, what can I do to offset this? Folks, roughly a 2-minute shorter shower per day more than covers your electricity and water consumption needs for AI. And this is for an average data center. We're doing a lot better in Canada, and we'll talk about some of those advantages in just a moment here. Adi, on the data center side and electricity, anything you want to add here?
Yeah, so as Griffin mentioned, Nvidia has a lot of software engineers compared to hardware engineers. HP is kind of like reverse in the sense we have a lot of hardware engineers and experts, as well as software engineers. So on the hardware architecture level, we're seeing a lot more advancements as to how you deploy these large compute-heavy workloads and GPU infrastructure, right? Modular data centers is becoming more and more prevalent, where they're actually being deployed closer to where the energy is actually being generated. You see a lot of neoclouds doing this, and we're seeing a lot more of this type of deployment happening too. Direct liquid cooling DLC, that's also a big topic of concern. That also drives down the actual power to actually cool these systems as well. And recycling that excess heat energy to different means like heating homes, or maybe using that excess heat for greenhouses too. We've seen that in Europe, and HP has actually helped design some of those use cases, how we can offload some excess heat into more, efficient ways too. So
Thank you. Glenn, do you want to tackle the Albertan advantage here and how this helps? I think when we try to bring in new power capacity, nuclear can take a really long time. The Site C dam in BC took a couple decades to realize, and by the time it was built, the excess supply was already eaten up by demand. So what's to be said about building data centers here?
Well, I think that, ultimately Canada, as a whole are positioned to lead here, and Alberta specifically. I've lived here in Alberta for over 40 years. Family members work in the energy sector. I've served the energy sector for a number of years in my career. And we lead the globe on getting access to sources of energy in the highest environmental regulated world in the world. We are the highest regulated, and for good reason. So I believe that we can, and we will develop energy ethically. I think that we can deliver it sustainable. We can utilize the innovation that we have in driving what we've driven out of our resource sector here in Alberta in very remote areas. And we can tie together the innovation from the energy sector to deliver ethical AI in Canada as close to net zero, or in some cases net positive, that no one else in the world can touch, which will also then attract international investment into Canada because we can build it better, we can build it safer, and we can build it more ethically.
Great, thank you. And folks, we often focus here on the risks and maybe some of the issues that come with the environmental concerns, but let's also recognize AI's role in creating a lot of the technologies and benefits that we're going to need as well. I'm particularly excited in the material science space. You know, some of the biggest objections to driving an EV, well, the range isn't far enough. What if battery chemistry got to the point where you could get 1,000 kilometers out of a car? Solar energy production today, those panels are 20% efficient. What if AI enabled the simulations and the tool and the material sciences that got that to 40% efficiency, and for the same surface area, you could get twice as much generation? There's a lot of opportunities there as well. Any of you guys want to add to maybe some of the ways that, in terms of environmental preservation and caretaking, that AI is going to assist, or should we move into the economic aspect of this? Go ahead.
There's countless use cases. I think one that I'm particularly excited about is just on the climate side, extreme weather prediction. We saw an announcement recently from Environment and Climate Change Canada where they put the first hybrid AI model into production. So now we can predict extreme weather events with, I think previously we could do it with high accuracy 4 days in advance. Now we can do 5 days in advance. And no airplane in Canada can take off without those weather models, right? So one of many other such examples we can offer, but I mean, I'm super excited about I'm optimistic about the prospects here.
I think we all are. Glenn, huge announcement last week. Really proud of, and thank you both from HP and Nvidia for helping us build these factories. It's a big accomplishment, and it's going to secure our compute for Canadians and our organizations. We committed to building 3 more in BC last week. This is part of the Build the West program. Glenn, how does this propel Canadians forward economically and also within the AI arms race?
You know, I liken it back to, you know, about 150 years ago, we built a railway. And one of the reasons that we built the railway was external threats of annexation. And part of British Columbia joining Confederation was the commitment to build a railway. And that's what we're doing now. We're building that infrastructure for the digital age. And we announced 3 data centers in British Columbia last week. It's part of our national rollout. We believe that we need to have national infrastructure across the country. It will drive all the things we've talked about before of the innovation across Canada. We are seen as leaders globally for the development of ethical AI, as I've said. And from a financial perspective, that development of intellectual property, keeping it here in Canada, is only done by building that infrastructure in Canada. And when I mentioned before about building in an ethical way, a sustainable way, these centers are world leading in the environmental impact of a data center.
Did you want to quickly talk about the water recycling use and reuse and why that's impactful?
Sure. So some people, you know, after the announcement were wondering why did we choose a site in downtown Vancouver?
Seems odd.
It could,
at first glance.
Yeah, as someone who's been in the data center business a long time, you typically look at large bodies of water as a threat to the data center, but it actually positions us very well in a couple of different things. So proximity to subsea fiber cable to Asia Pacific. So I talked about it be able to attract international investment. We need to move those electrons as close to the source as possible, and so that gives us that advantage. But the actual site that we have chosen, so as we have talked about before about making the hardware more efficient, we know that they need, you know, with liquid cooling, you got to have liquid. Our site on West Georgia is actually going to take the rainwater off of the roof of BC Place. And we're going to store that rainwater. We're going to utilize that rainwater to cool the electronics. Our CEO talked about using electron twice. And so by leveraging the electricity that we'll get from renewable energy, from hydro, we will cool it with rainwater, and the excess heat will be sent to approximately 150,000 homes. So we believe that it may become, obviously may is a big word here, the first net positive data center, because we'll actually take the heat from this data center to heat 150,000
That's brilliant.
homes.
Brilliant. Adi, anything you would like to add? We've built our first 2 sites here, lots of H200s, primarily air-cooled. We're moving into this new architecture. Anything you'd like to share about that process and the change that we're seeing from an infrastructure perspective?
Yeah, so a great question. So typically when you're moving from air-cooled to more, I guess, liquid-cooled architecture, you're actually able to have a lot more density per rack, meaning that you can fit a lot more those high-performance compute nodes into one rack. So you don't have to use up a lot more space. So ultimately, your data center becomes more compact, and you have more space for adding in other things too, which is really nice. And a lot of people don't always realize it. When you talk about DLC, we might think of water actually going to the system. Well, we actually have 2 primary liquids actually cooling the system. One is actually accessing and touching the chips inside of these servers, which is like propylglycol, PGW, which is like more environmentally friendly. It runs for years and years. It's a basic check, and it cools the chips pretty efficiently. And then the water actually gets transferred into what we call like a CDU. It can be in-row or in-rack CDU, which kind of just has a transfer between the propylglycol that you talked about, and then the water just cools it down. But the propylglycol is actually is what's cooling the chips inside the servers too. So that's a little bit more technical, but yeah.
No, thank you. Thank you for sharing that. And if the audience has more questions at the end, they can dive a bit deeper. You still here? Oh, went silent for a second. So now, having sovereign compute, and we're all working together to enable this for Canadians, is important. But being able to access it affordably as a researcher or a startup, to have the maximum positive impact of your product or service on society is a completely different thing here. We've had the federal government recognize this, bringing $2 billion of investment through key programs like the Sovereign Compute Infrastructure Program, the AI Compute Challenge, and the AI Access Fund. This is going to be a big topic here. How can startups and mid-market companies access grants, access infrastructure, make partnerships, other than attending these wonderful sessions and doing some of the networking here? Glen, let's start with you. How would you help a startup today that's struggling to get access to compute, which we hear about on a regular basis?
Yeah, it's a great question. When we built our first AI factory in Rimouski, Quebec, we recognized that these startups are very thirsty to get access to what we had built. They are typically locked out just from a financial perspective. Grants are great, but the grant process can be very long. You have to make sure you fill out all the right forms the right way, and then it kind of goes into the ether waiting to hear if you've been selected for the grant. Don't get me wrong, this doesn't happen without the federal government launching these programs, but the government is by nature slow and methodical. And so what has been happening is these research organizations have been courted by hyperscalers, and those hyperscalers will offer tens of thousands of dollars, if not hundreds of thousands of dollars in grants, in credits, I should say. And then what happens is that, those organizations that are thirsty or starving for access to that type of infrastructure, they start building in the tools that are provided by those hyperscalers, and that gets locked in to the hyperscaler.
And quite often not a Canadian region either.
And quite often not a Canadian region. So all the things we talked about protecting your intellectual property, having that, access to what you build taken away is all a real threat. And so one of the things that Telus did is that we announced a partnership with an accelerator based out of the Canada region, LSpark, and we launched that to give access to that startup community in a very similar way that the hyperscalers will, but it actually gets that development happening in Canada. And the great thing about partnering with the accelerator is they also then bring mentorship. Telus is involved in bringing mentorship. Telus Global Ventures is involved in listening to their ideas for potential investment. And we need to continually build out this idea that I call it the hotel, that we will build the infrastructure, and we want startups to come in and check in and use what we build to help create that AI ecosystem nationally. And this only happens with direct sponsorship into that community. And so we're really, really proud of our AI Catalyst program because we've onboarded the first 5 organizations into the factory, and they're leveraging the tools that our fine friends here have helped provide. And this is how we drive that innovation. This is how we find that next Canadian startup to massive, massive scale.
And the diversity of what that first cohort is building is just unbelievable. We could do a whole other session on some of these up and coming technologies. Griffin, Addy, anything you'd like to add to the conversation here?
Yeah, I'll add very briefly that I think that's a great description of some programs that are important to be aware of. Nvidia does have its own program called the Inception Program for startups. We've onboarded, I think, hundreds, if not thousands, of startups. At this point, part of the new set of benefits of joining the Inception Program include discounts on hardware. So if you're looking to build out your own kind of even mini AI factory, I think that's a great resource that exists there for you. And then I think Glen and Addy both touched on tools. I would say the other thing I hear a lot with startups that we talk to that really want to move fast is that they're usually using some endpoint that is hosted somewhere else, right? They're using an API. API service, pointing their application to some model that's hosted somewhere else in the world, and they're thinking about, well, how do I bring this into Canada? How do I bring it on-prem? And so I tend to point them to, I think, Ad, you mentioned like NIMs, but a lot of the tools that we have that make that a little bit easier. So NIMs are these containerized packages that are free to use and play around with that'll just let you bring a Llama model on-premise or a model from any of our partners, OpenAI, right, Anthropic, or build your own model and bring it on premise. So I would encourage any startup who's not aware of these tools that exist that make their life easier to go and inform yourself about what is out there, because trying to reinvent the wheel, especially as a startup, is a difficult game to play.
Yeah, I'll also add that many of the data center or data scientist teams I talk to at different companies and different institutions, research institutions, if you give them 5 GPUs, they're going to utilize all 5 GPUs. If you give them 10 GPUs, they're going to utilize all 10 GPUs, right? So it's really important to have access to these compute resources and make sure it's known and available for researchers, organizations, enterprises, businesses in healthcare, pharmaceuticals, where all these innovations are taking place. So awareness is also a key factor because if we deploy them, I think, Glenn, you mentioned it, people will come and utilize it. So come utilize it, yeah.
Yeah.
Sorry,
Go ahead,
and I'd like to build on that. So 2 things. The Nvidia relationship has been very, very good for Telus for a number of reasons, but one of the actual drivers is all of their programs, they do such a great job of reaching out to us and say, have you heard of? Have you heard of this company? This is a Canadian company that's looking to do X. And having that relationship, because we don't always know who's out there, right? Like, Telus is, we typically look at organizations by how many cell phones can we sell you. So there's going to be 4 or 5 person organizations that are out there that have brilliant ideas. And they're going through the forums that our partners are putting on, and they do such an amazing job of sending it over to us to work with them through our programs. And the second piece is, the great point about if we give them 1 GPU, they'll consume it, 5 GPUs, 10 GPUs, 16 GPUs, but they're not using it, 7 days a week, 24 hours a day. And so what we're going to launch next with our AI factory is our models as a service. And it is such a great way to get multiple startups access to these models for the work that they need to do in a very efficient and economical way. And so, instead of just saying, here's a bunch of GPUs, use them for free, this is now, here are a bunch of models that align to what you're trying to grow. This is why we need those mentors out there working with these organizations to say, have you thought of the following things, to help align to getting them into this factory to prove out their hypothesis, to build their business, and develop this technology that we so desperately need in Canada.
Yeah, thank you. And you all brought up a new theme here that wasn't covered in the earlier definition of sovereign is sovereignty doesn't necessarily mean moving from a hyperscaler to Telus's AI factory. That may not be sovereign enough. You may want on-prem local deployments. You may want to do that at the edge. Maybe that's what sovereignty means to you, and you need to work that into your business case as well. Let's talk about talent, folks. This whole thing doesn't happen without talent. There's a career fair happening here alongside the event. Please take a look, do some networking, come visit us as well. And I often think about this popular yet unfortunate notion that Canada is incredible on the research side of R&D, but maybe struggles on the development side. Now, if I'm a startup and I have an idea that I think is going to change the world and benefit everyone, I wouldn't blame them for maybe looking elsewhere if they can't find the right amount of infrastructure compute, the right amount of investment, the right amount of talent to bring into the organization, compatible or favorable regulatory climate as well. But let's just make the case right now. If you're a builder in AI, building something incredible, what are the reasons for staying in Canada and keeping this talent ecosystem healthy and alive here? Maybe Griffin, start with you.
Yeah, I'll just speak from my own experience because I was in that position about a decade ago. I was studying in grad school. This was kind of right after the big bang of deep learning. AlexNet was causing a lot of excitement, and I was looking at how can I apply some of those skills that I've learned to a career. And I mean, it was the reality back then was just like the opportunities outside of Canada were pretty intriguing, right? Because typically there was companies outside of Canada that were just a bit more fast moving, right? And they had some pretty attractive opportunities. But I was very lucky and fortunate that I really wanted to stay in Canada. I mean, I'm from Canada. My wife is from Canada. We wanted to raise our kids here. So I was able to find an opportunity at Nvidia in Canada to help Canadian institutions. But since then, I mean, Nvidia, I can just speak for our experience. We've hired hundreds of more people in Canada. The large enterprises are all hiring very aggressively in Canada, everything from federal government to the big banks to hospitals, research institutions, startups, et cetera. So I think the prospects are as good as they've ever been in Canada. But moreover, I wanted to comment that this situation is actually as true as it is today as it was when I was looking 10 years ago, which is that I think these amazing AI practitioners, these talented researchers, want to work on hard, interesting problems. And to work on hard and interesting problems, you need the right tools. And so I've actually always considered AI infrastructure, right, large GPU clusters, almost as a recruiting mechanism. And I think now that we've got these great projects, such as what Telus is doing, to bring that modern bleeding edge technology into Canada, I think now is as good of a time as ever to argue that a really talented researcher coming out of, just say, Amy, has the ability to work on these tools in a way that is globally as interesting as any other opportunity they might be aware of. So I think we're moving in the right direction. I think there's always more we can do, but I'm glad to see that we're able to create the circumstance to try to attract this and retain this talent as much as possible.
Thanks. Yeah, if we look at the intersection of these circumstances that's required to get this magic happening and the innovation staying domestic, what are some areas we could do better, Glen or Adi?
Yeah, so as I think Griffin and Glenn mentioned, right, the more we build the compute infrastructure, there's a lot more researchers, talented people in the research space too. We're seeing a lot more impact when we get more of these incubators or ecosystem partners to actually spread the word and invest. HP has done a lot of investment in Canada recently because that's where the power of compute and obviously customers are too, right? So we're seeing that where the talent is accumulating, we're seeing a lot more investment into that too. So government grants, subsidies, programs to actually make that more attractive for companies to hire locally too. And we're seeing a lot more outside and foreign investment as a result of that as well. So awareness is always something we can do better, but the talent is here. It's in this building, right? So, and companies see that, and they're investing a lot more that we're seeing. So
it's great to hear.
Yeah, I think it comes down to solving problems, right? So innovators there's a problem they're solving for. And as Canada diversifies, to solving our own problems, and how do we attract investment from other countries who are looking for their problems to be solved. I met with a delegation from Korea last week, of all things, about the investment in Canada, because they say the talent is here, and we are a safe harbor for development. And in the geopolitical world that we're living in, that is incredibly important. So you think about, how does the government, how do private organizations, how do we put problem statements out there for these organizations to solve, for Canadian organizations, for Canadian citizens? We're working with a group that is looking at leveraging AI to early detect breast cancer. So cancer is a global problem, and our ability to work with this Cancer Institute to drive that innovation solves Canadian problems and helps solve global problems.
Absolutely.
And that's how we develop the skill that we have in this country, and that opportunity retains
Agreed.
that capability within Canada, drives high-paying jobs, drives the ability to, as I said before, solve the problems of today, and enables that ecosystem to continually take that data that's driven by it and leverage it for other problem statements that our country has and that happen around the world.
I'm glad you brought in such an important and dramatic use case here. I think we're often talking about B2B impacts of sovereignty. Are you going to have enough compute? Is it under the control and legal jurisdiction that you're happy with? Do you have enough diversity in your supply chain so that you won't have outages and that you're going to be able to scale properly? Return on investment and the ROI on the sovereignty business case, as we look through the stack, there's the control and regulatory aspects, there's capacity, there's the environmental component, which definitely has a value, maybe harder to quantify, but definitely needs to be worked in there from an ESG perspective. Maintaining talent here in Canada so that this ecosystem can thrive. All of that to me fits on a business case overall for AI and sovereign AI compute in Canada. When you're working with customers, how are you helping them frame the economics of this? When can they expect a payback if they're going for a hybrid approach? You know, they're in the hyperscaler, they're moving to sovereign compute, or they're moving workloads across. What are some of the aspects that you can quantify earlier on, build into the business case, and what are some of the longer looking aspects there?
Yeah, I mean, I think there's a couple of streams here, right? So one of which, obviously, in large organizations, leveraging artificial intelligence to become more efficient, to become safer, drives efficiency. It drives the ability to produce more, especially in the energy sector, to be able to develop solutions to get that product to market safer, more efficiently. Drives ROI, but probably the biggest one is this ecosystem that's going to get built in Canada. The talent's all here. The talent's in across the country will help us grow our own GDP, because we are now seen as that, as I said before, that safe harbor because of how we treat our data, how we create the guardrails for ethical AI development. That we are now going to be an export. And we have a unique opportunity to leverage our natural resources that we have to not diversify from it, but leverage what we have to grow other areas of growth by that foreign investment that's going to come in. And so you hear at the development stage, organizations who are trying to build those solutions, they want to not just sell to Canadians, they want to be able to build it and sell it worldwide. You talk to financial organizations, they're bringing their data back home, especially leveraging AI to keep all of your information safe. They believe that the ROI will be there, that there will be almost an ethics tax as organizations are developing their AI, and that will be a way to generate revenue, generate more customers as we walk that line of AI development, the ethics around AI development, the impact to AI development. Canada is very, very different than other global players, that we think about the impacts across that paradigm.
And over a longer term. I think if you're thinking about 5 or 10% productivity gains in a business, if it was turned off, you're like, I could live with that. When it comes to drug discovery, medical imaging, the ability to detect fraud on your credit card, these are things that can impact us every single day. On the ROI and business case, Addy, Griffin, anything you'd like to add? Addy?
Yeah, definitely. So we're talking with a lot of enterprises and different companies. A lot of them are hybrid by design, so meaning that they leverage public cloud, on-premise resources, sovereign resources too. So what that actually means is that when we talk about the token economics, they're using open source models as well as the closed source models like Anthropic Claude, right? And they might see a similar or increased efficiency in using open source models while paying much less, right? Because you're kind of underlying only paying for the compute resources, not paying per token per se too, right? So it really depends on the workload that these institutions and organizations are actually deploying, and find the right fit as to where to deploy them, right? Whether it be cost, efficiency, or data locality too. So,
Thank you.
Yeah, and I'll just say very, very briefly that I think we need to move away from the notion that sovereignty and performance is a trade-off. I think historically, unfortunately, it's been true that if you're a company that wants to deploy something in production and you want Hopper GPUs, you want Blackwell GPUs, you can really only get them, from the US, for example. And so if you want to bring something into Canada, you're using an older GPU, right? You're using a less performant GPU. And so I think what's great about like this Telus project, for example, is we're bringing bleeding edge technology into Canada. It's the exact same chip in Canada as it is anywhere else in the world. It's the same networking stack. It's the same high performance storage. And it's the same CUDA libraries and CUDA ecosystem. And so I think that the ROI story, will be the same whether or not you're running it somewhere else or running it in Canada and in a sovereign infrastructure. But we really need to change that mindset, because historically there has been a trade-off. There has been a tax that you pay, a performance tax in Canada, but I think that's the gap. I think that's what we're trying to address, because you want to make sure that, if you want to be competitive, if you want your deployment to be competitive globally, you have to make sure you're running on the latest technology, and that's what a big value in this project is.
Yeah, and if I may as well, is that the trade-off of that you spoke of, and there's other trade-offs that you make. If you want to do cancer research, and your cancer research is leveraging real data, like real people's data, to go into the US, you now not only, you may not, period, because of privacy laws, the compliance, the regulatory demands to get access to that available platform slows the actual innovation, because clearly you don't want your data just being sent anywhere, right? So by building out this sovereign infrastructure and the mandate of that, whichever customer that is, whether that's a provincial entity, a small business, whatever it might be, you own your data. You're not obfuscating responsibility for your data. And so by coming into that guardrailed ethical AI development, you own your AI, you can actually now innovate because you're using real data and not just a subset or junk data to prove out your hypothesis. And you think about the years of that cycle, if you can start leveraging AI to help solve for breast cancer, then you're now moving to treatment faster. You're now saving more lives. And that's why I do what I do, is that outcome. I mean, yes, my boss wants me to sell more of your stuff and sell more factories and all that kind of stuff. But that's why I do what I do, is that outcome.
As exciting as the servers and the racks are with all the blinky lights, it's what our customers are building on top of it that's so impressive. I do want to save some time for Q&A here with the audience. So last one, rapid fire. Your call to action, whether it be to startups, regulators, investors. Just quickly, what would you like to see a lot more of happening in Alberta and in Canada with respect to sovereign AI? Griffin, start with you.
Yeah, I would say just move fast. We've got the talent, we've got the energy. Increasingly, we have the infrastructure. AI is changing every day, every week. You need to move fast to keep up with it. These data center projects take a lot of planning and a lot of advanced thought. So the faster that you can act, I think the better the outcomes will be.
Yeah, to add on to the point, just kind of getting your hands dirty, right? Playing with the latest and greatest latest models, how to deploy them, how it's actually working inside our organization, like playing with these new models. It's very important to actually get hands-on because, as Griffin, you mentioned, week to week, day to day, it changes, right? So the way we can implement that into our daily activities, which we probably already have, like, is very important too. So just getting hands-on and getting dirty with AI in hand. So
Don't let good be the enemy of perfect. Right? If you have a great idea, we've got a great idea here in Alberta. We need to build a in Alberta solution. We need to build for Albertans, and we need to build for Canadians. And waiting to make everything perfect, we get left behind.
Agreed. And I would just make a call out, any energy projects that are going on, get those moving as quickly as possible. Same idea here. These chips are going to be starved without the energy supply, and we have a real structural advantage here in Canada, favorable climate, so we may as well be doing it here. I keep thinking, like, not all tokens are created equal. If there's greener tokens and browner tokens, let's be the purveyor of the greenest tokens possible in Canada. So we will now, and actually before the Q&A, in case there's not time after, thank you all for being up here. Thank you for helping us build these wonderful AI factories and securing this compute and next wave of intelligence for Canadians and Canadian organizations. And we will open it up to Q&A. It's pretty bright, but if there are any questions, get your hand up and I think a mic will be passed around. Do we have a mic runner around? Maybe, maybe not. Glenn, let me do, if you don't mind. We'll do this on the fly here. There you are. Introduce yourself and go ahead with the question.
Yeah, thank you so much. My name is Tao. I work for the Canadian Standards Association. So thank you all for the work that you're doing in building these sovereign AI factories. My question, I work in the space of healthcare, and data privacy is a very big thing. How do you see us building our own sovereign compute and data in Canada when we have these jurisdictional barriers that exist?
yeah, I can take that question. So that's a great question, right? Especially with these regulatory bodies, especially in healthcare and finance. How do we take those regulations and bring it to the sovereign aspect, right? So when we're building these sovereign AI factories, we're building it from the ground up and keeping in mind regulations. So we work with healthcare providers, financial companies to make sure those regulations like HIPAA, so on and so forth, are compliant. So the way you're operating right now, whether it be in your maybe on-premise data center, making sure that process is the exact same when you introduce a high-performance compute. And having an audit trail is very important because sooner or later, legal is going to come knocking at your door. Finance might come knocking at your door. It's like, hey, we did this. Are we allowed to do this? Here's the audit trail to back that up. And that's actually a key factor that Telus actually has that expertise and knowledge to actually work in all these industries, so they've gone through it before. So we're able to actually provide the audit trail, those logs, those keys to actually back up your claim and do it in a safe manner in a regulatory format.
And to that point, we do it today. So we've been in the data center business for over 20 years. Part of that, we actually host healthcare data today across the country. So we build a fully compliant solution. I talk about those guardrails. So when you go towards your compliance team, your regulatory compliance team, your safety compliance team, your information compliance team, we already build our infrastructure out to satisfy those needs and those audits and things like that.
One more question right here.
Hi, I'm Jivanshi, and I've been working in healthcare AI for the last couple of years. So my question is, what decision factors and barriers influence who get access to AI compute resources, especially the groups who are building localized domain-specific healthcare models?
So with the applause, obviously they loved your question because they were clapping as you were speaking. So if you could just repeat it again, please.
Yeah, so my question is, what decision factors and barriers influence who gets access to AI compute resources, especially the groups building localized domain-specific healthcare models?
Yeah, it's a great question. So that's one of the reasons why we're building out this accelerator layer, is that we look across the different areas of research. We're working with a number of research universities across the country to build that, not only give their access, but to help create the onboarding that's required for organizations to come to say, I've got a great idea, this is what my hypothesis is, we need access to compute. Setting up those programs, like those Catalyst programs, are what are absolutely 100% necessary, and us broadcasting that it's available, right? So us actually taking to the airwaves, coming to things like this, to let people know that we're doing this and that we're absolutely building those programs to have that onboarding, because we can't solve for those challenges unless we're working with the direct people who are solving those challenges. And then our discussions with the different provincial entities about that investment that we also need across the country, from an infrastructure perspective, and it's not just money, but it's the own regulatory things we have to go through to build out more data centers, to build more infrastructure, to get power allocated, to get land allocated. Working with those entities, utilizing this idea of how do we onboard organizations is how we do this. And so absolutely, if you want to come up to me afterwards and we can talk about how we can get you into our Catalyst program.
Yeah, just to top up there, I really appreciate the question, and I think this curiosity and concern around who's going to get access to the compute if it's limited, and will it just be the highest bidder gets all of it type scenario, where some of the maybe most impactful, most meaningful discoveries that have a longer timeline to get to monetization will not get the right treatment. I think the government programs have been set up quite thoughtfully in this regard as well. Some of the pillars are dedicated towards compute clusters specifically for research, and I think healthcare tech is going to be a good portion of that, with an eye that eventually these GPUs will need to be replaced, and the compute needs to be refreshed, and that's built in it as well. How are those research groups with these big clusters able to monetize some of their leftover compute capacity and be ready to replace that infrastructure when the time comes? So I think there are good programs, but it is a good call to action nonetheless that we need to be doing more in this space as well. Thanks all for your engagement and your questions. Hope you have a really good day and enjoy the rest of the conference, and hope to meet some of you out there as well. Thanks a lot, and Addie, Griffin, Glenn, thank you.
Thanks.
Thanks so much.
Upper Bound is proudly produced by AMI, the Alberta Machine Intelligence Institute. As one of Canada's 3 national AI institutes, AMI is dedicated to advancing AI research, adoption, literacy, and startup creation. We thank you for joining the AMI community here at Upper Bound. To learn more about our work and connect, visit ami.ca.